Welcome back. As always, make sure to subscribe to my channel for more chemistry videos. The topic for today is Lewis structures, and I have a video on introduction to Lewis structures, so make sure to check out that video if you haven't already. And in that video, we talked about the total number of covalent bonds and lone pairs based on the group number. So it's a real good idea to take this list and memorize it by creating some flashcards where on one side you put the group number, such as 1A, and then on the other side put the number of covalent bonds and the number of lone pairs, because it will be very helpful to memorize what the number of covalent bonds and lone pairs are for each group. It will also help to memorize the number of valence electrons for each group as well. Okay, so when we are looking at Lewis structures, there is a process to it. And I know it seems daunting at first, but as we go through and keep doing examples and take it step by step, it will become easier. And if you follow this process, it will make your life a lot easier as well. Okay, so you don't necessarily have to memorize this list, but just keep using it and keep getting into the pattern of going through this process. So the first step is that we're going to determine the total number of valence electrons in a Lewis structure. And after that, we've got to determine the central atom and what's going to be our outer atoms. And our outer atoms we're going to place around the central with that top, bottom, left, and right method that we've done before. Okay, or you can do it clockwise around. But again, top, bottom, left, and right are the places that you want to use. So once we determine the central atom and arrange the outer atoms, then we're going to start forming those single covalent bonds. And remember that a single covalent bond represents 2 electrons. Okay, we're going to save hydrogen for last, and we'll figure out why probably in the next video when we have multiple central atoms. And we don't want to form more covalent bonds than possible based on the group number. And what I mean by that is based off of this table. So carbon typically has 4 covalent bonds, and we don't want to exceed that number. Okay, after we have formed our single covalent bonds, then we're going to start distributing the rest of the electrons that we have as lone pairs, first around the outer atoms and then around the central atom. And again, we always want to keep this table in mind, what the number of lone pairs should be depending on the element. Once we've formed all of our lone pairs, if our central atom or if any atom still doesn't have the correct number of covalent bonds, then we may start to form multiple bonds. And again, that's what we'll do in the next video. And the last step is to always check and make sure that our structure has exactly the total number of valence electrons that we started with. No more and no less. So let's dive into some examples. The first example that we're going to look at is CH4. And the first step in our process is to determine the total number of valence electrons. And remember that each element, the number of valence electrons you can find based on that periodic table. So carbon is in group 4A. And for group 4A, remember that that means it has 4 valence electrons. And hydrogen being in group 1A on the left-hand side, it's going to have the same number of valence electrons as lithium, so it'll have 1. Okay, so if we want to total up all the valence electrons that we have in CH4, carbon has 4 valence electrons, and hydrogen has 1 valence electron. But then we've got to multiply by how many carbons and hydrogens that we have. Well, in the formula, it's assumed that we only have 1 carbon and we have 4 hydrogens. So we've got to multiply the 4 valence electrons for carbon times the 1 carbon that we have. And for hydrogen, we don't just have 1 hydrogen, we have 4. So we've got to multiply the 1 valence electron for each hydrogen times the 4 hydrogens that we have. And so we've got 4 for carbon and 4 for all the hydrogens, giving us a total of 8 valence electrons. And just remember that that first number, that was the number of valence electrons from the periodic table, and that second is the number of atoms that we have. Okay, and we're multiplying those two values together and then adding them all up for all the elements. Okay, so we have a total of 8 valence electrons. And then the next step was to determine the central atom. And remember, one of the tips is that hydrogen will never be your central atom. So the only option we have left is carbon. So I'm going to put carbon in the center, and then I want to arrange the remaining atoms around carbon. So I want to add those 4 hydrogens, and I tend to do it in a counterclockwise in a clockwise order, but you don't necessarily have to. So 1, 2, 3, 4 hydrogens. Okay, once I've added all the atoms in the system, next I want to start forming single bonds from the central atom to each of those outer atoms. So I'm going to connect that carbon to each hydrogen. Okay, and we don't want to form more covalent bonds than possible based on that group number. And again, that is coming from this table. So if we look at the element carbon, carbon should have 4 covalent bonds and 0 lone pairs. And hydrogen should have 1 covalent bond and 0 lone pairs. So we're looking for each carbon to have 4 bonds and each hydrogen to have 1 bond. And that's exactly what we have, is the carbon has a total of 4 bonds, each to 1 hydrogen. And then the last step is to check and make sure that we have used up all 8 valence electrons. And remember that a covalent bond, or a line, represents 2 electrons. Okay, so that's important. So if each line represents 2 electrons, then we have 2, 4, 6, 8, or a total of 8 valence electrons. And so our final structure is the carbon singly bonded to 4 hydrogens. Okay? Now let's look at a second example. Next we have NF3. And remember that the first step is to determine the total number of valence electrons which you get from the periodic table. And this time we're looking at nitrogen and fluorine. So nitrogen on the periodic table is here in group 5A, which means that it has 5 valence electrons. And fluorine is in group 7A, which means that it has a total of 7 valence electrons. So going back, nitrogen has 5 and fluorine has 7. Remember that first number is the number of valence electrons coming off the periodic table. And then we have to multiply that times the number of atoms that we have in our formula, where it's assumed that we have 1 nitrogen and 3 fluorines based off of our subscripts. So I have 1 nitrogen and 3 fluorines. Okay, so that gives me a total of 5 valence electrons coming from the 1 nitrogen and 21 valence electrons coming from the 3 fluorines. Add those together and we get a total of 26. So once we have our total number of valence electrons, then we want to determine the central atom. And remember that that's going to be the farthest left and down on the periodic table. So if we look at nitrogen versus fluorine on the periodic table, nitrogen is farther to the left, and therefore that needs to be our central atom. So nitrogen is our central atom. We're going to surround it with the 3 remaining fluorines. And remember, I'm just going to go clockwise. Okay, then we want to form single bonds from the central atom to each outer atom. so that nitrogen will form a single bond to each one of those fluorines. Keeping in mind, based off of that table, that nitrogen should have 3 covalent bonds and fluorine should have 1 covalent bond. Okay? And looking ahead, nitrogen hopefully will have 1 lone pair and fluorine hopefully will have 3. But as the structure is, nitrogen has 3 bonds, so it's happy, and fluorine has the 1 bond. Each fluorine has 1. Now, we want to distribute the remaining electrons as lone pairs around the outer atoms first. So that means we're going to start with those fluorines. And remember that fluorines should have 3 lone pairs. So I'm going to add 3 pairs of 2 electrons around each fluorine. Okay, and then place any remaining electrons on the central atom. It may be a good time to stop and check and see how many electrons that you've used up to see if you have any left to put on that central atom. Hopefully we have 2 electrons left to put on that nitrogen, but let's count them up. So on the fluorine here, there's 2, 4, 6, and if we want to, we can count up all the lone pairs first. So that'd be 6, 8, 10, 12, 14, 16, 18. And then remember that each bond counts as 2 as well, so 18, 20, 22, 24. So total, I have used 24 valence electrons, and I started out with a total of 26. So that means I have 2 left, and that's great because 2 left means I can put those last 2 on the nitrogen. And now each fluorine has 3 lone pairs and the nitrogen has 1 lone pair. And we've used up all 26 valence electrons. So our final structure would be the nitrogen attached to 3 fluorine atoms. And then each fluorine has 3 lone pairs of electrons. And the nitrogen should have 1 lone pair of electrons. All right, let's do one last example. Let's try SF2. So if you want, this might be a good time to pause the video and see if you can do it on your own. So the total number of valence electrons comes off that periodic table, and this time we're looking at sulfur and fluorine. Sulfur is directly underneath oxygen, and oxygen is in group 6A. So remember that oxygen and sulfur are each going to have 6 valence electrons. And then fluorine, based on the last example, should have 7. Okay, we only have 1 sulfur and 2 fluorines. So 6 sulfur plus the 14 from the fluorines should give us a total of 20 valence electrons. Once we have our 20 valence electrons, we want to determine the central atom, which is the farthest lower left on the periodic table. Comparing sulfur to fluorine, sulfur is farther to the left and down, and therefore going to be our central atom. And we add the 2 fluorines surrounding sulfur, form our single bonds to each fluorine from the sulfur, which is at the center. And sulfur should have 2 bonds and fluorine should have 1, so we're good there. And then we want to distribute the remaining electrons around the outer atoms first, keeping in mind that fluorine should have 3 lone pairs. And based off of that table that we've been looking at, sulfur should have 2 lone pairs. Okay, so we'll put 2 lone pairs on sulfur and then count that up. You should get a total of 20 valence electrons, and this is your structure for SF2.